Right now I'm watching Bill Nye trounce this guy online about creation, and so it's kind of funny. But I'm taking a break from that to help you guys out. Period 7, you didn't get as far. Yeah, that happens. So we're going to go back to number 2 on the notes, and this is all the notes. These are notes examples. If I look at this ordered pair, I see that it's 1, 2, 3, 4, 1, 2, 3. Forgive the lack of resolution on this, but this happens sometimes with this program. So that's the ordered pair 4, 3, which means that it has a vertex of 4, 3. So if I'm going to put the general form y is equal to a times x minus h squared plus k, I want to substitute 4, 3 in for hk and get x minus 4 squared plus 3, but I don't know the a value. And in order to figure out the a value, I need to substitute another point. Let's throw that one in. That is the point 1, 2, 3, and then up 1, 2, 3, 4, 5. So I'm going to put that in as one of my xy points. And I'm going to solve that equation with 5 is equal to a, I still don't know a, 3 minus 4 squared plus 3. 3 minus 4 squared is 1, and this would be 5 is equal to a plus 3. So a was equal to 2. And if I go back and kind of plug this in, and that's kind of the last step, I'm going to plug a right back in. Actually, not there. I'm going to plug it in here. And my final answer is to say y is equal to a times, or it's not a, sorry, 2 times x minus 4 squared plus 3. You can actually plug that in your calculator and check that if you'd like, but we'll move on. Number 4, if the vertex is negative 5, 6, I'm going to go ahead and write y is equal to a x plus 5 squared plus 6. Remember that h is opposite and k is the same when we plug it back into the standard form, or sorry, the graphing form. So I need to solve for a. Well, if the x-intercept is negative 1, that's going to be negative 1, 0. And so I actually plug that back in as y is equal to a, oh, sorry, not y, kidding, 0 is equal to a negative 1 plus 5 squared plus 6. Negative 1 plus 5 is 4, and 4 squared is 16, so this is 16a equals negative 6, or a is equal to negative 3/8. Putting that back into the regular equation, that would be y is equal to negative 3/8, parentheses, x plus 5 squared plus 6. The last example on this page, I think it's the last example, yes it is, the values of a and k. So basically this is saying we need to figure out what a and k are. And I have this kind of equation right here. So I know that negative 1, 2 is an ordered pair, and I know that 3, 6 is an ordered pair. If I plug negative 1, 2 into this equation, I'm going to get 2 minus k is equal to a negative 1 minus 3 squared. And simplifying that equation a little bit, I'm going to get 2 minus k is equal to negative 3 minus 1 is 4, and 4 squared is 16, so I have 16a. We're going to lock that as equation 1, and then we're going to do this again with the other ordered pair. 3, 6. If I plug that in, I get 6 minus k is equal to a times 3 minus 3 squared. Simplifying that equation, I get 6 minus k is equal to 0. And that's going to be my second equation. And this is sort of like, well, this is exactly like a system of equations. 2 equations, 2 unknowns. My unknowns are k and a. So really what I need to is to solve this. Well, if I look at the second equation, it's already really solved. K would be 6, and plug it right back in up here. 2 minus 6 is equal to 16a, or a is equal to negative 1/4. And since the question just asked for a and k, we can give it to them right there. We're going to skip ahead. Both classes we were able to graph this one and put them in graphing form, but we did not get to number 9. So let's move to number 9 with the full A through F, actually A through G here, graphing. Number 9, this is not in graphing form at all. So what I want to do is I want to isolate the two x terms and factor out a 3, leaving behind an x squared minus a 4x. I'm going to go ahead and start the box step right now. I'm going to use plus box, and then plus 7 minus a box. Problem, that's not really a box that I subtracted because it wasn't really a box that I added. That was actually a 3 times that box, so I'm going to have to subtract the box times the 3. We did the little house thing in both of them, the little roof or whatever. So once you figure out what goes in that box, half of negative 4 squared is positive 4. Half of negative 4 squared is positive 4. Okay. So this is really plus 12, so this is really minus 12. And I want you to see that. This times this is 12, and this times this is 12. Actually, negative 12. And so that balances. Back to the equation, y is equal to 3, x minus dos squared. And then that's really 7 minus 12, or negative 5. So part A, we have to do this before we even get to part A. Part A is asking, is it a min or max, and what's the vertex? Well, the vertex would be 2, negative 5, and I know that it's going to be a maximum because this is an upward parabola, because it is a positive a value, so that means it's going to be a minimum. For part B, the axis of symmetry, well, let's go ahead and plot 2, negative 5. Right 2, down 5. And I'm going to plot the axis of symmetry as a vertical red line here so you can see it a little bit better. And that red line carries an equation of x equals positive 2, which matches. That should be the same as this. Part C, well, the graph is up, right? Part D, if there are real roots, well, since the graph is up, and I'm just sketching, that's a terrible sketch, but here's a better, okay, that sucks too. It's definitely going to cross in 2 spots, so we're going to have some real roots. Let's go ahead and solve for that and figure out what they are. To solve for the roots, I'm going to go ahead and take the graphing form and say 0 is equal to 3x minus 2 squared minus 5. And with 0, I'm going to actually add 5, divide by 3, so 5/3 is equal to x minus dos squared. Take the plus or minus square root of both sides, so I have plus or minus radical 5/3 equaling x minus 2. Radical 5/3 is the same as radical 15 over 3, because it's really radical 3. And remember, radical 5 over radical 3 is going to rationalize with radical 3 and radical 3. So that's where that comes from. And if I add 2, I have 2 plus or minus that. And I'm going to accept that as a fine answer. I'm not going to make you guys add them up unless you want to. But I also want to put approximately where they are. So take out your calculator. I'm going to hit pause while that opens. And here's my two values, 3.29 and 0.71. So that is 3.29 and 0.71. I'm going to plot those approximately. One's going to go here, and one's going to go here. I'm going to zoom in and check that they are in fact symmetrical, and they are. That's good. Zoom back out and go with part E, which is the Y-intercept. We're going to be really smart, and I'm going to look back up, and I'm going to substitute 0 into the original equation. Why would I do that? Because it's really easy. If I substitute 0 in back here, I get to drop that out, and I end up with y is equal to 7. That's really, really, really convenient. So my y-intercept is 0, 7. Now, of course, you could check to plug that in to the graphing form, and in fact, this is an excellent, excellent way of checking if I have the graphing form somewhat correct. And we're going to talk about this in class the next time I see you. If I plug 0 in here, I get 2 squared is 4, 4 squared is 12, times 3 is 12, 12 minus 5 is 7. That's going to match that 7. If it didn't, then I would know something was wrong. So that's a great, great way of checking. And if I plot 0, 7 on the graph, I get the y-intercept. And then let's put the same point on the other side of the axis of symmetry. We want 2 other non-symmetrical points on the curve. Okay. I'm going to qualify that one and say that this 2 extra points, well, maybe we only need 1, and here's why. If I put x equals 1, which is something we're definitely missing right there, plot x equals 1, I could do this from either the original or the graphing form. Let's do it from the graphing form. 1 minus 2 squared is 1. 1 times 3 is 3. 3 minus 5 is negative 2. I'm going to put negative 2 there, and I'm going to put negative 2 here. So the original point I was about to make is, why is it really kind of pointless to put in more points than this? Well, look at how steep this is. I really have plotted all the good points I possibly can, and everything else is going to be kind of pointless. So I would say another point is not necessary. Say another point not necessary. And you should easily, clearly see why. It's graphed and we're done. Let's go to the next one. Number 10. If I have number 10, that is also not in graphing form. So I'm going to put this in parentheses and factor out a negative 2, giving me an x squared minus a 4x. Put a box, minus 9, and that's really minus a box with a little house on it, and inside the roof of that house is negative 2. Because negative 2 times that box we added, and so we have to subtract negative 2 times that box. Graphing form, well, let's put the box in. That's going to be 4 and 4. So my equation is y is equal to negative 2, x minus 2 quantity squared. This is minus 9, but then plus 8, so minus 1. Part A, I know that my vertex is 2, negative 1. It's a downward parabola, so the vertex is a max. For part B, after I plot 2, negative 1, my vertical axis of symmetry is x equals 2. And I'm going to write that as x equals 2, again with that matching this. Part C, state the graph is inverted or down, well, we'll just call it up or down. This is down. Part D, if there are real roots. Well, since it's down from this point, we get to save a lot of time by saying there are no real roots. Later on, we'll ask you to find imaginary roots, and you guys already know how to do that right now. But for graphing purposes, we don't need to. Part E, let's do our y-intercept check. If I plug 0 into the original equation, I get 0, negative 9. That should be my y-intercept, and I'm going to graph that and its opposite point. Here and here. Going back up, if I plug 0 in right here, just as a check, I get negative 8 minus 1, or negative 9. That works. That's good. So that just kind of confirms it and makes sure that I probably did this right. Part F, let's put another 2 points that are not symmetrical. So if I try x equals 1, I get 1, let's see, negative 2 minus 1, I get negative 3. So 1, negative 3, and that means 3, negative 3 is also a point. We're kind of, again, in this situation where that's about as best as I can graph. If I put any more points on there, they're going to fall off the grid. So really not necessary. I've got the maximum number of points I really need to show to make that look good. So that's as good as that will go. Last one. Let's do this. This is a little bit of a challenge one. If I factor a 2/3 out, x squared, dividing by 2/3 is the same as multiplying 4 times 3/2, which gives me 6. So this is plus 6x plus a box, and plus 6 minus that same box with a 2/3 multiplied by it, because we factored the 2/3 out. Half of 6 squared is 9, and 9 there. So I get y is equal to 2/3 x plus 3 quantity squared. Then, let's see, 2/3 of 9 is 6, and 6 minus 6 is 0. So this is the graphing form. You can put plus 0, but you don't need it. My vertex is negative 3, 0. Right there. And it is an upward, so that this is a min. Axis of symmetry would be x equals negative 3, which again I'll plot as a red vertical line going through the vertex. Next, for part C, this graph is upright. For part D, here's the tricky thing. Of course there are real roots. You see it. It's right here. It's the only one. It's the vertex. My real root is negative 3, 0, and it is a double root. I know it's a double root because if I looked at the equation 0 is equal to 2/3 x plus 3 squared, look, don't worry about the 2/3. What number would make that true? Negative 3 would, and we used to say it's a double root because of that square. This should be consistent with what you guys remember. So how do we get more points? Well, the y-intercept is going to be valuable. Look back up at the original equation, and I see the y-intercept would be 6. And if I plug 0 in to the new version, it's also 6. So 0, 6 is going to go down there. And I'm going to put its opposite on the other side. And now I actually have lots of points I can test, or sorry, I can do for a t-chart. So I'm going to do, for xy, I'm going to try -2. And if I do -2, I get 2/3. So we'll do that the best we can, -2 and 2/3. Oops. And then put its other point on the other side. Then we're also going to want -1. -1 plus 3 squared is 4. 4 times 2/3 is 8/3. And 8/3 is really 2 and 2/3. So if I kind of put that 2 and 2/3, 2 and 2/3. Oops, that's not in the right spot. 2 and 2/3 would be right here. So that's plenty to get this going. You could put 1 if you really, really want to be picky, but I think 1 would be off the graph. Let's see, 16, 32/3, 10, and well, almost there, but that's fine. And that's it. Just kind of take a look at that, and we're done. These notes are available online. They're going to be under the period 7. I'm going to copy them over to period 1 too, so you see them. They might not be called printout. They might get a name change when I start just kind of organizing this. So you'll see that sync up here in a second. Bye-bye.